In this video, we're going to talk about queues again, queues just like before, and that they're the first in or the first out. But this time, instead of modeling them with arrays, we're going to model them with linked list. Okay, so the linked list is going to give us, again, as always, the flexibility to not have to determine the max size. It's going to go on forever, as long as there's memory in the system. Okay, so we also avoid the problem with the arrays. It was weird when you're trying to delete from the front. We had that whole problem of not using the space, and we had to go back with a modulo operator to figure all that out. So it's a little more straightforward. Okay, so here we have, I've got on the right the commands that would have been performed on this queue. So we have this is the first one added, okay, and so forth. Okay, so there are two pointers we're going to have to keep track of in this. Okay, we're going to have our queue front, okay, which is going to point to here. And we're going to have our queue rear, which is going to point to the end, to there. Okay. So basically the way this is going to work then is if we're going to add an element, okay, it's going to work just like it does when you're adding to the end of a linked list. Okay, so you'll create your new node. We've done this before a lot of times. Okay, you'll give it its text, whatever it is. Okay, you will set its link to nothing. It's the end of the line. Okay, and then you'll look at the queue rear and point queue rear instead of pointing it to that one. You will now point it to this one. Oh, sorry, I should have first I had to point queue rear to here, and then I can point the queue. So queue rear link has to go to the new node, and then queue rear goes to this new node as well. Okay, so that's when we're adding to the list. When we delete, it's just a matter of deleting from the front. Okay, so we're going to capture the information. We'll typically create a temp. Okay, so temp will equal to the queue front. Okay, and once we've got that, so then temp will point to here. Okay, we're going to change the queue front and point it to queue front link. Okay, so it's going to point to there. Okay, and then we delete temp, which will delete all of that stuff. Okay, so that's basically what we're going to be doing. Okay, so it's a little more straightforward, I think, than it would be with the arrays. Okay, so let's take a look at the code and what this is going to look like. Okay, remember this is still based on the same ADT that we had before. Okay, so we still have that. Okay, so we're going to call this one linked queue type. Okay, so I'm in my queue directory and I still have my queue.att. Okay, so I'm going to go ahead and do queue linked queue type.cpp. Okay, so we're going to start this. Okay, since it's going to, we'll do our IO stream as always. We'll include as well the queue adt.h. Okay, interesting. Okay, since it's a linked list, we have to first do our template. It's templated, so we have to do our template class type. Type's a variable name. Then we do our struct for node type. Okay, which has the type info. And it has a node type pointer called link. Okay. You want to spell struct properly. Okay. We then have our class definition. And then it's a semicolon. Spacing was off, so I knew. Linked queue type, which is going to inherit in the public fashion from the queue ADT. Okay. So we should have that code together. Okay, go ahead and close it properly or I'll forget. Okay, so in this case, we're going to have the following functions. These are public functions. Okay, so this is just like what we had for the queue type itself. We're going to have our linked queue type operator equals for overloading the assignment operator. Okay, which takes a constant linked queue type. And this doesn't put a name, so we're going to put other queue. Okay. Because again, I'm doing these this way. Okay. We have Boolean function for it is empty queue. Constant, which returns whether or not the queue is empty. Our bool is full queue. Okay, which in this case, it's never that's always going to return false. Okay, since we're doing it as a queue, it will never, or as a linked list, that will never be full. Okay. So we have the initialized queue. Spelled the same way every time. Okay. Which is going to set things up to its initial conditions. Okay. We're going to have a function to return what's at the front of the queue as a type. And just like before, we have the back. We have a void function to add to the queue, which takes a const type element. Okay, we have a delete queue. Which takes nothing and removes the first element of the queue. We have our default constructor on the linked queue type. We have the copy constructor, which will take linked queue type called other queue. We have our destructor, which gets rid of the memory we have left over. It's tilde and queue type. Okay. And then for private, we're going to have a pointer to a node type, the Q front. And we're going to have another Q rear. Okay. And that should do it. Okay, that should get us set up here. Okay, we probably will have a copy queue function that's private. Okay, I'm guessing like before, they're going to leave that as an exercise for us, but that should be the basic idea there. Okay, so the next thing we're going to do, we're going to start putting in some of these functions. Okay. Okay, we'll start with the is empty queue. We don't have to worry about the is full queue because it never is. Okay, so the is empty queue, we're just going to return the result of the Boolean expression Q front is equal to the null pointer. Okay, so if that's true, then it's an empty queue. If not, it's not. Okay. As far as initializing the queue, okay, so we've got a little bit of work to do here on this. Okay. And we're going to start here with a pointer called temp. Okay. So the idea here, it will initialize it to an empty state. Okay. So it has to start by removing all existing things that are there. Okay. So we're going to traverse the list first, getting rid of everything. Then we're going to add the new one. Okay, basically is what we're doing here. Okay, that's why we're doing this temp. Okay, so we have a node type, temp. We've seen this before. It's the basic idea. We get rid of things. We're going to say while the Q front is not equal to the null pointer. So as long as there's still things there, there's still items in the list. Okay, we're going to let temp be equal to the Q front. Then we're going to move the Q front down the line by Q front equal to Q front link. Okay. Then we're going to delete that temp to free up that space. Okay. So that will go through and delete everything that's there. If it's there, if there's nothing there, it'll do nothing. It'll immediately stop. Okay. Then we're going to do our Q rear equal to the null pointer. Okay. So now we're at our initial condition. There are no elements to the queue. Now, if we did, which would have just set Q front equal to null, then we would have accomplished this goal, but we would have left a memory leak. There'd be memory out there that was not freed up. This is going to free up our memory, and then it's going to set the end state here is the Q front is equal to null pointer, and the Q rear is equal to null pointer as well. Okay, so unlike with the arrays, we don't have to worry about keeping track of the count. Okay. And again, we had to do that with the arrays because we needed to know the difference between an empty array, or an empty queue and a queue of just one element. Okay. Okay, let's next look at the add queue. Okay. Which is down here. Okay, so it's going to take in this new element. So again, we've seen this before. We have our node type for a new node. This is the same exact code as we used when we're adding to the end of a linked list. Okay. So now we have to actually allocate the memory. New node is equal to new node type. Okay. Our new node info is going to be equal to the new element that we're passing in. And our new node link is equal to the null pointer. Okay, then we have a couple of cases to think about here. Okay, we're going to see if Q front is empty. If the Q front is equal to the null pointer, okay, then we know there's nothing at the list, so we can set both Q front equal to new node and also Q rear equal to new node. Okay. Else there's something there. Okay, so we can now add this at the rear, and we have a Q rear pointer. Okay, so we should be okay. So we're going to let Q rear link, which is currently a null pointer, it's going to be equal to the new node. Okay, and then we're going to change that Q rear pointer to be equal to new node as well. Okay, which is what I just showed in the graphic beginning on the whiteboard. Okay. That should do it. Okay, do we have enough parentheses? Yes, okay, or enough brackets, we're good. Okay, so that's going to be what we're going to do to add. So adding to the rear. Okay, then we've got the front. It's odd that it does it in this order, but it does. Okay, the front is going to return whatever the Q front points to. Okay, so for the front, we're going to have an assert. Okay, so we need to make sure we go add our C assert include. Okay, we're going to say Q front is not equal to the null pointer. Okay, we're then going to just return that Q front info. Okay, I'm going to do back while we're at it. Very similar. It's going to assert that the Q rear is not equal to the null pointer. Okay, it's then going to return Q rear. Okay, so we've got that taken care of. Okay, we can now move on to the delete Q. So delete Q again doesn't return anything. It's just going to remove it from the beginning. Okay, so to be able to delete the memory or free up the memory, we're going to have to do a node type pointer called temp. Okay, it doesn't have to be called temp, but there's no reason to change that. Okay, we're going to say if not is empty Q. Okay, so there's something there. We're going to let temp be equal to the Q front. Okay, we're then going to move the Q front forward. So Q front is equal to Q front link. Okay, we're then going to delete temp. Okay, and then we can say if at this point the Q front is equal to the null pointer, then we're going to set the Q rear equal to the null pointer as well. Okay, that's all we're doing there. Okay, then we have our else. Okay, so that is that. That is that. Our else is going to be tied to this if. Okay, so if it's not the empty queue, then we're just going to have our message. Okay, that that we cannot remove from empty queue. Okay, that's all we got there. Okay, that takes care of the else. And that's the end of our delete queue. Okay. Let's look then at the constructor. So with the constructor, the only two bits of data we have here are the queue front. And when we create it, the queue front will be equal to the null pointer. And the queue rear is also equal to the null pointer. Okay, that's all we have to worry about with that. Okay. So what's left here, okay, is going to be the destructor and the copy constructor and reassigning the called something. We're changing the assignment operator, okay, in order to avoid the whole idea of shallow copies. Okay, so that's all left for exercises for you. Okay, so again, you can start on that if you want. We'll be doing that in class on Monday. Okay, so that should be it, right? That's the idea here. So this has the same ADT, okay, as, and I may have some typos. We'll have to find those if you do. Okay, I guess I can do that real quick. See if anything obvious pops up. All kinds of stuff. Wonder what it doesn't like. Starts off. Yeah, I've got some issues there. Oh, I may need to declare the type again. Looks like it's a lot of type issues. Okay. Well, I'll go ahead and clean all this up before I move it over to the temp file. Okay. But I wanted to look at while we're here, the queue type or the queue ADT. Okay. So again, these are the functions that we have to implement. Okay. Then we add whatever else we have to add in order to make it work. Okay. Okay. So that should do it for queues normally. Okay. We're going to cover queues on Wednesday as well. With that, we'll talk more in depth and do another big example, I think, with queues. Okay. If you have questions, as always, let me know.